So this is the second part of the 6.2 notes from pre-calculus on solving the law of cosines. And we have a couple of application problems. The first one is a bearing problem. Man walks 900 meters on a bearing of 10 degrees west of north. He turns and walks 400 meters on a bearing of 75 degrees west of south. What is his distance from the starting point? So we have two different legs of this journey. Each time we have a bearing given, we're going to draw a new origin, a new xy axis, and the first one is going 10 degrees west of north. So he's not going directly north, he's going 10 degrees west of north. So the first part of the journey is going to look like that, and our little 10 degrees goes right there, and the length of this is 900. Then changes course, so we're going to put a new xy axis in there, and now he is going at 75 degrees west of south. So he's going in this direction, and this time our 75 degrees is going to go right there, and he travels that distance for 400 meters. So here are the two legs of the journey. The question is, what is his distance from the starting point? So here's his end, there's the start. We are trying to find that distance. Here is the triangle that we're working with. So I'll take this triangle and draw it again, and put down just the important information. This is 400, this is a length of 900, and we're trying to figure out this length, so I'll call that length x. And as far as the angles go, we want to know how big is this angle at the top, because then we have a side angle side. Part of it is 75 degrees, but if I look at the drawing a little bit more, here is north-south, transversal, north-south. So not only is this angle down here 10 degrees, but its alternate interior angle is 10 degrees, making this entire angle at the top 75 plus 10, or 85 degrees. Because it's a side angle side, we can use the law of cosines. Specifically, x squared is equal to 400 squared plus 900 squared minus 2 times 900 times 400 times the cosine of 85. Use your calculator, take the square root of that, and we get a distance of about 952.50 meters. Last thing in this section 6.2 is on finding the area of a triangle when you know side, side, side. And for that, we'll use Hero's formula, sometimes called Heron's formula. So these two chapters dealt with solving triangles as well as finding areas of triangles. This formula deals with if you know the three sides of the triangle, namely A, B, and C. First of all, you have to calculate the semi-perimeter. The perimeter is the sum of all three sides of the triangle, and semi means you take half of that. So you calculate this S value, add up all the sides, and divide by 2. And then the area itself is the square root of S times S minus A times S minus B times S minus C. And that will give you the area of the entire triangle. An example of how you would use this, you have these three sides of the triangle. So first of all, figure out the semi-perimeter. Add those together, 21, 38, so it's 19. And then so the area is square root of 19. 19 minus 10, 19 minus 11, 19 minus 17. Multiply all of them and take their square roots, and you get a final area of, you simplify that, 12 root 19, and that is about 52.31 units squared.